Yeah, good morning everyone. Today we shall see the continuation of abstract class concept. As I mentioned to you, any class which has at least one pure virtual function, that class will be abstract class. So let's see how we can define an abstract class and how we can use it to inject, abstract concept into a class. So let's see the example with, let's say we have a payment gateway which has only one method. Let's say void pay, and you are going to accept some amount here. I'm not going to define it here. I'm going to make it pure virtual. Any method which is equated to 0 will be pure virtual. And of course, we should have the keyword virtual here. Okay. So any class which has at least one pure virtual function will be an abstract class. This definition we have seen last time. The implication of this is abstract class cannot have objects. You cannot instantiate object of a abstract class. We shall see the usefulness of an abstract class as you move along. This abstract class will be implemented by two particular gateways. So I need to have a class. Let's say PayPal is one payment gateway, which will implement the payment gateway that we have defined. So we saw last time what happens when I publicly extend the base class. So what is public here will become public. Most importantly, any method you declare here should be public already. Otherwise, by default, everything will be private. Okay, so I'm not going to have any data members here, just one method in the public section, and that too pure virtual function. Now, any class which inherits from abstract class has to implement this pure virtual function. So in its public section, this PayPal has to implement the method pay. So within the body of this, you can say amount paid by PayPal gateway. I'm just taking very simplistic example just to illustrate the concept. In a more complex scenario, this will involve a lot of steps. So this is the implementing class. So PayPal is one concrete class which will extend the abstract class. Now second class, let us say you are doing a UPI. Last time we considered Paytm, right? So let's consider Paytm. And again, this, if it implements the abstract class payment gateway, this class also has to implement the same method in its public section. I simply copy paste here. Okay. But instead of PayPal gateway, I would call it as Paytm gateway. So you know which method is being called when I use this class subsequently. Now these gateways are now very much there. Let's say one particular shopping cart, online shopping cart will use this payment gateway. For example, let's have a class. Some online store is using this shopping cart class. So in this cart, you might have certain items bought. Let's say here you can have some data members like ring online store name, whatever. And within the public section, you could have a constructor. So I'm going to put some default name here, online store, as let's say Amazon. Now within the shopping cart, I have to accept the payment. For that, I will make use of this abstract class gateway, that is payment gateway, which is abstract. So I'm going to create payment gateway star. I see payment gateway being abstract, I cannot create object of this class, but I can create a reference variable. Okay, so here I can use payment gateway. So just see the variable name is all in small case. It's just a reference variable of type payment gateway. Now this payment gateway has to be initialized by a particular gateway. As a argument here, I will accept whatever payment gateway the user chooses at runtime and use it to initialize the data member payment gateway. And this has another method, let us say checkout. So when you check out, you have to make the actual payment. So you just have to call pg arrow pay whatever is the amount, and this amount can come from the checkout. See, the member variable is this payment gateway, and this argument pg is coming as a argument into the constructor. All right. So we shall see how all this plays out, and before you make the payment, you can put out uh, which online store you are visiting. So here online store is online store name. Now, before we see the rest of it, let's quickly look at what all we have done. We have declared one abstract class which has one pure virtual function. There is no definition of pay. How do I pay depends on which payment gateway I'm using in particular. For example, PayPal will pay it this way. Okay, it may have very complex logic here before making the actual payment, but for simplicity, I'm just saying paid by PayPal gateway. Similarly, the same payment gateway may be implemented by Paytm. So this also accepts amount as an argument and makes that payment, whatever is the payment amount. All right. Now, the reason why I have to use abstract class is that the interface is same. Both classes will be implementing the same method pay, right? You don't have one method pay PayPal and then another method pay Paytm. It's just the same method pay. So the interface is same. The implementations are different. Now the advantage of doing all this is whatever payment gateway the shopping cart uses will be generic in nature. That is, this payment gateway variable which I've declared here can either receive PayPal gateway or Paytm gateway. So the process of sending a different kind of payment gateway and make the payment happen is called as injecting a functionality into the class. So here payment gateway, what it receives in the constructor will decide how the payment will be made during the checkout. So when you actually check out, okay, when you say pay amount, it depends on which pay method will be called. Will it be called from PayPal or will it be called from Paytm? Depends on what is coming here as an argument. Okay, so let's see the implementation of this in a concrete way. So here I have to first create PayPal object. So let's call it as P. And then you have the Paytm and call it as PT. So these are the two objects which are created. Okay, and then you have your shopping cart. Now shopping cart is accepting one argument. If you see here, the constructor of shopping cart has one argument, which is expecting a gateway. Now, payment gateway is a base class of both of these, easily pass the address of either P or PT. So let me first send P. Okay, and now if I say sc dot checkout, and if you send some amount here, what should happen? Currently, the gateway is pointing to PayPal, so the payment will be done by PayPal. Okay, so let's run this and see, right? So as you can see, abstraction demo, online storage Amazon, 5,000 paid by PayPal. Okay. So the payment is done by PayPal because you are sending the address of PayPal as the gateway which shopping cart should use. Suppose you don't have PayPal account with you, you have Paytm. So just change this to PT. Now see what happens. It should switch over automatically to Paytm gateway and you say 5,000 paid by Paytm gateway. So you don't have to change code anywhere else. Just change it here. Depending on what object you pass, okay, accordingly, the payment will be done by a particular gateway that is implementing the abstract class, right? So do you see the injecting a particular payment gateway into the shopping cart object? Now this
Sir,
is this
sir,
is
can you
yeah,
uh, can you go up, sir? Just
okay,
shopping cart.
okay,
Okay, online store. Mm,
yeah. So it's just a data member here string on
mm,
to know which
mm,
shopping cart I'm currently using.
mm. Okay.
And this payment gateway, as you can see, it is a
Mm,
abstract class reference variable,
mm.
okay, which can take different objects at runtime depending on what you're passing here. The PG will receive either P or PT.
PT, yeah.
Okay. So likewise, you can have any number of implementing classes. For example, I just have two now. Can I add one more? So let us say you want to make payment through debit card or credit card. I can
Yeah.
change this to, let us say, credit card.
Mm,
And credit card also has to make the payment like this only,
mm,
right? But this will be through credit card, okay? Number ending with, you can put some stars and last four digits like that. Okay, so this is another class which is implementing the same gateway. Now,
Yeah.
if I create just 1 minute credit card, yeah, everything else is same. So here I have to create a credit card object and pass it here. It should work seamlessly without any changes anywhere else. All right.
Mm. Yeah.
So this is called as light coupling. That is, the classes are lightly coupled. Your shopping cart is lightly coupled to the payment gateways through the abstract class. So abstract class will help you to pass different objects of different classes depending on the requirement and depending on the availability. For example, you have only credit card, so then you send credit card accordingly. The payment will be made. But if you
Okay.
have Paytm, then you send Paytm.
Okay. We can also put this in the choices and
Ah, yeah, yeah.
right.
You can put a menu here, and depending on the user choice, you call shopping cart constructor, and accordingly, when you say checkout, it will happen. Now,
Okay.
this is similar to the Lambda functions that we saw. There also we are injecting something into the methods of a class. So here you can inject the objects only into the constructor of the
Mm.
class and call the checkout method. All right. So when you build large software systems having tens of hundreds of classes, keeping the classes loosely coupled is an advantage that you can replace one class and put one more without making changes anywhere else, isn't it? So, for example, you have a two-wheeler and a spark plug which you use. If it's gone bad, you can remove it and put it some other company's spark plug. Spark plug. It would still work. Why is that possible? Because of the loose coupling. Every spark plug manufacturer conforms to certain standard and builds his spark plug so that you buy from any vendor, put it and start using it. Same thing applies to software. So you should build classes when you want to connect them because classes cannot exist in isolation. All are related to one another or all are dependent on another. So that dependency has to be loose coupling so that you have the flexibility of sending object of different classes and get the things done. Is this concept clear?
Shall we try it out?
Yeah, yeah, you just try it out. That should give you little more confidence into what I've done. Yeah. Shall we move on? Okay, so let's see another example. Now, we all have seen the car example. Let us say we have a generic steering. You know, in a car, we have steering, and using steering, I can turn the car left, right. Okay, so let's say turn left is one of the method, and which is virtual and abstract, pure virtual. Like that. I'm taking one more example to get more concretization of the concept of abstraction. And this should be in the, similarly, we could have one more method, turn right. Now, this pairing could be implemented by different car manufacturers, isn't it? So let's say we have a class Maruti car, which will inherit from steering. And whenever any class inherits from abstract class, it is mandatory for the subclass to implement both these methods, right? If it doesn't implement, then I have told you that the subclass also become abstract. Means Maruti car class cannot have its objects if these are not implemented. So it is compulsory for the subclasses to implement them. Now, let us say you have very old model of Maruti car, maybe Maruti 800. So you can just put out name of the car and here in the public we can have just one constructor name and it will be initializing the car name. All right. And here this Maruti car has steering also as one argument. Now here what I can do is I will just put out that car name turning left using manual steering. So I have implemented turn left using this string. Similarly, turn right I have to implement. Obviously, same car will not have manual steering and power steering. This should be again manual steering, just that this is turning right. So we have a Maruti car which is turning it left right using manually. Similarly, if I have another class, let us say maybe Kia, which publicly extends steering. And then within the body of this, we can have a string car name, and within the public part, we can have a constructor Kia, which is accepting a car name like that, and it is going to initialize the car name. And this is again extending from abstract class. It should implement both the methods. So I simply copy paste here. But Kia being a modern vehicle, it might be using power steering. So just see how abstraction can be used in many different ways. Here I can create base class object, that is we create a object of this, passing let us say car name. Similarly Maruti. So now you see k dot turn left if I do, and m dot turn left. You will get two different answers because the object on which you are executing the methods are different. The methods are the same, but objects are different. Here also some kind of runtime polymorphism will happen. As you can see, this car is turning left using power steering, and this car is turning it left using manual steering. So this is another example. Is another example where you can use the abstract class concept. That two subclasses can implement the same abstract class in two different ways. And whenever you call the methods, how the method behaves depends on to which object it is pointing to. Okay, I'm not injecting any method into a class constructor, but when you call the same methods on two different objects, you will see the effect is very different.
Sir,
Yeah.
it's, sir, actually, if there is if I want to have the turn right, if I want to pass the angle in
Okay.
the turn right,
Okay.
so can I use the same method like that, or do I need to again
Again, see this
a
this
new one?
this has to be changed now.
Oh, okay.
Okay,
So if we
without
have to pass
yeah,
something,
without changing
but
this, you cannot implement it differently.
okay. Okay. So you mean so suppose let us think like I have implemented the turn left, which is abstract of the public steering, meaning the
Okay.
class steering.
Yeah.
But in my Maruti car, I create the same name with in the same particular function
Hmm.
with different same function name with the passing the parameters.
Yeah. Here you can
Uh,
turn left
Turn left
with
and
some
pass
angle.
the angle, int angle or float angle.
Okay.
Okay.
So here you can say see out turn left whatever
Uh,
by angle.
and,
This is very much possible.
okay.
The subclasses can have their own separate methods.
Do we need to at line number 20 we have defined as virtual in line number 14 and
Yeah.
20. Do
This
we
is
need that?
this is not required actually.
Yeah.
Yeah.
Okay.
If you want to further extend Maruti car,
Okay.
then
Martika. Uh-huh.
virtual is required. Yeah, you're right.
Okay.
Okay, so now if you go to Maruti here and just say m dot
Turn left at
turn
90 degrees.
left with some angle.
90 degrees. Okay. Okay.
Okay, so it should work fine. Turn left by angle 30.
Mm.
Hmm. So along with the overridden methods, you can have your own concrete methods in the subclasses. That is perfectly fine. Okay. All right.
Okay. But you need to but the overriding of the same virtual function cannot be possible.
Yeah, I mentioned about different types of inheritance. One of those was hierarchical inheritance. So in this, the base class A is extended by both B and C. Okay. Now, if it were confined to only this level of inheritance, if we had ended with B and C, that there wouldn't have been any problem. But if you extend class D from B and C, so class B and C, if they are used to extend class D, then you have a diamond problem here. I was mentioning about diamond problem. So what is this diamond problem and how do I solve it? Hmm? So just to see what happens when we have a inheritance like this. Now you have a method here show what happens when I inherit into B. So there will be a copy of show here, and this C also will have a copy of show. But when you inherit both B and C into D, which one to inherit? A copy of this or this? Okay, so this ambiguity will result, and accordingly we have to sort this out. Okay, diagrammatically, and again the constructors will be a problem. Now look at this diagram here. When you implement class D deriving from B and C, B will have constructor of A, C will also have constructor of A, and A has its constructor. Okay, so the D will see these many constructors. Actually, it should see only constructor of A at only once, isn't it? So if I implement class D and create an object of D like this, if you have implemented C out in each of the constructors, then the output will be like the constructor of A called, constructor of B called, again constructor of A called, and constructor of C called, and constructor of D called. As you can see, constructor of A is called twice. Okay, this should not happen. Okay, so the diamond problem results into repetition of the constructor of A, once with B, once with C, because copy of constructor of A is in B also and also C also, and in D you are inheriting both from B and C. So how do I alleviate this problem? Similarly, there will be a copy of show in B and also in C. So there will be ambiguity and you will not be able to proceed if the same copy of show is there in B and C, right? So in that case, we have a answer for this. The ambiguity that results of having same show method in two base classes, and this is called as diamond problem. Now to resolve this, what you have to do is you have to virtually inherit from class A. That class B should use virtual keyword before public when you are mentioning the class extension. So when you inherit from class A, you have to virtually inherit A. Similarly, you have to virtually inherit A for C. And now if you inherit from C and D, then that problem will not be there. That is, the copy of the constructor will be maintained only once. All right. So just to see this in action, let me program and see what happens when I have this diamond problem. So if I have class A and let us say it has its constructor of A and L, and there is a show method. So we will have two subclasses of this, class B and C. So this will be class C, this will be class B. So class B will have its own constructor, class C will have its own constructor. Let it show this. And we are not going to override this method because it is in the public section. If you derive, copy of show will be there in both B and C by default. So what I've done is I have class A with its constructor and one show method. In class B has its own constructor, and the show method anyway will be derived because we have to derive it from class A here. Okay, and similarly class C will derive from class A only. Now this class D, which derives from B and C, what will happen to this? So it will have its own constructor. Okay, So now if I just create one object of D, just like this, what do you think what will happen? So there is a multi-level and multiple inheritance also, and it is a hierarchical kind of a inheritance, and there's a diamond problem, right? So as I mentioned to you, when you create an instance of D, the order of invocation of constructors will be from base class to subclasses. So the class which is at the top will be class A. So constructor of A will be called, then constructor of B will be called, then constructor of C will be called, and constructor of D will be called. So if everything is okay, you should get the output like this. Constructor of A is called, constructor of B is called. So far it is good, but again constructor of A is called, as you can see here, because B has a copy of A and C also has a copy of A. Okay, and when you create an object of D, both of these will in turn call the constructor of A and A here. So the repetition of constructor is a problem. Do you see this problem? Hello?
Yes, sir.
Okay, now if I want to avoid this, I have to use a keyword virtual here. So that B and C will not have a copy of constructor of A, they will refer to A indirectly. So now if I just check, you should get only one copy of constructor of A. Okay. So the diamond problem is solved using virtual keyword when you want to inherit from the base class. It should be done only with B and C, not here.
Not written.
Okay. Because the problem was caused by only C and B. Class B and C were causing the problem. They were maintaining a separate copy of A. Now, if you make it virtual, they will maintain only one copy of A through a reference. And when you create object of D, you will see that the repetition is suppressed. Is that fine?
Uh,
Sir, in class D, if we pass public A, then that is that possible?
Where?
In class D, in class D,
Hmm.
class D.
D, okay.
So in D, A, B, C, right? What if we use A? We cannot do that.
Here,
Class. In place of C, we cannot use A.
you can, then that will be a different kind of, inheritance.
Okay.
If D it derives from B,
Hmm.
okay, and D again derives from A, it will not be a diamond problem. Okay.
Okay.
So there should be a cycle formation. Only then that problem arises. That is happening
Okay.
when you are doing like this, and
Okay.
only then that repetition will happen, and you have to use virtual at that time.
Okay.
Not in other scenarios like multi-level inheritance or multiple inheritance. Okay. That time it
Okay.
perfectly works fine.
Uh, Sir, one more question.
Yeah.
So here, public B and public C, right?
Yeah.
So both have virtual public A.
Yeah.
What if you don't declare virtual public? I mean, don't pass virtual in one of these classes. In that case, again,
Again, one of them will give a problem. No.
will
For
give a
example,
problem.
if
Okay.
you do this, then C will have a copy of A.
Of A. Okay, so now the class D is going to inherit from B, C as well as A, right? Class D, 27.
Hmm?
D. Class D.
What was your question?
So, right, see, in this case, class D inherits from
A.
B, I mean D, 27th, class D.
27. Class D.
Okay.
Okay. Class D.
Now class D inherits from B and C both,
Yeah.
right?
Yeah.
So B also has a copy of A and C also has a copy. I mean, C is also referring to A,
Yeah.
right? When
Yeah.
we.
Yeah.
So in that case, class D will also refer to A, right?
Refer.
I mean, it also inherits from
Yeah.
A,
Inherits from A. True.
but will. But again, it is inheriting through B as well as C, right? That
Yeah.
won't be a problem.
See, D is not directly from A. It is through B and through C.
Okay.
Okay. So without the virtual keyword, there were a separate copy of
Separate copies.
constructor of A and constructor of A in both A, B, and C. So that was causing the problem.
Yes.
Okay, so
Okay.
if you make
Yeah.
virtual,
Mm.
both the classes B and C will get a reference to the constructor of A, not a copy of constructor of A. That is how it
But
happens.
yeah, but my question is like when we are inheriting even the reference, there is going to be two references right now
Yeah,
from public key as
references will
okay,
be
that is
two.
okay.
References will be
Okay.
two, but they will refer to the same constructor.
Okay. Okay.
You got
Okay.
it, no?
Now yeah,
Yeah.
got it.
See, you recall your pointer
Mm.
concept. Pointer means what?
Mm.
Point to the
Mm.
same object.
Okay.
Okay.
Okay, sir.
Yeah. Hmm? Okay. So this is one problem which can be solved like that. Okay. Now there is a concept of virtual destructor. We have not seen this before. We have only seen destructor. Destructor is gets executed whenever the object is destroyed. That is, the object goes out of scope, or whenever you call delete. Okay, depending on where the object is created. If it is on stack, when it goes out of scope, it is deleted and destructor will be called. And if it is the object is on the heap, then you have to call delete function to delete the object yourself. So then the destructor will be called. But suppose you have a reference variable. There is a base class with a reference variable b, and if this b points to the subclass object, then if you say delete b, it calls only destructor of the base and not of the subclass. Okay, so let's see what happens when I have base class to subclass implementation, and you have a destructor getting executed. So let's consider one more example here. Now let's say we have a base class, and in the public section you have a constructor B and you have a subclass. Now we want to study what happens to the destructor that we define here. How do you define destructor? With this tilde symbol, this, and you can say destructor of base class. Similarly, the subclass will also have its destructor. Now we have these two classes. As I told you, uh, this base class reference variable can point to subclass object, isn't it? Okay, now we have to extend this from base public using public keyword. Only then the base class reference variable can point to subclass object. So whenever there is inheritance, single level inheritance, we can take the base class reference variable and make it point to the subclass. Now when using new operator here, it means what? The subclass object is created on heap or on the stack. Hello?
On heap, on heap,
On heap. So if I have to explicitly delete it, no?
delete, yes, delete, delete.
Correct? So what do you think, which destructor will be called?
Base,
Yeah?
base, base class.
But B is pointing to subclass object, no?
Base,
Subclass destructor should also be called. or both should be called in this case. The base class constructor is called, then subclass constructor is called. Destructor of base class is only called. Destructor of subclass is not getting called. Do you see this as a problem? What is the potential problem here if only the base class destructor is called?
If you are defining something in the subclass pointers or subclass variables will be
Yeah, you got
gone
it. You
for
got it
loss.
right. For example, let's say there is a new string like this. This object is created on the heap, right?
True.
Yes.
Now, do you think this object yes will be deleted automatically?
Mm,
It has to be done by the subclass destructor. No.
mm,
Now
we have
I have to
to
explicitly delete this.
delete
Say
stuff.
delete
Delete this.
yes. But if you see destructor of subclass is not called at all. Now this is a potential problem. That is the subclass dynamic objects will not be deleted if base class reference variable is pointing to subclass object. Now to elevate this, you have to declare this as virtual destructor. Okay. Now you see what happens. You'll see destructor of both will be called.
And in a reverse order.
Yeah, whatever
Or
order doesn't matter. But both destructors are
both
called. No,
should be yes.
both should be
But
called because possibly you have allocated another
no,
object here dynamically.
uh, no, what I meant is when you call the constructor, okay, when you call the base subclass constructor, the first thing will be called as the base class
Yeah,
constructor and then
that
subclass.
constructor is not a problem. Base class constructor called, subclass constructor is called. But
But
destructor was not getting called. Subclass destructor was
yeah,
not getting called.
right.
Right?
I was just going through the how it is going.
Yeah. So here also if you have a dynamically allocated memory, then this will be anyway deleted. No problem. Okay. So even if you don't have virtual keyword here, this destructor in the base class will delete name. But if you don't have this virtual keyword, you will see that only base class dynamic objects will be deleted. Subclass dynamic objects will remain in memory. So this leads to memory leak. Okay. So this problem, if you want to elevate, you have to make the base class virtual. In that case, the subclass destructor will also be called. Right. So now there will not be any memory leak. All of you agree?
Yeah.
Okay. So why the destructor has to be virtual? You should understand in the scenario wherever the base class reference variable is pointing to subclass objects. All right. So
Okay.
yeah,
Sir, I have it might be like basic question. Okay.
yeah.
So we use a lot of virtual in C++,
Okay.
right?
Okay.
So like essentially we might use it for a class or function, whatever it is.
Okay.
The purpose is we are referring to that function. I mean, is it same? I mean, the core of why we use the virtual function.
Yeah. Virtual means as I
When we
told
use
you,
for class or function, huh?
there's a difference between virtual and actual, isn't
Huh,
it? So
right.
when something is virtual, it means something actual exists. That actual has to come.
Yes.
So you have the
Yeah.
option of implementing the actual. So the
Hmm.
actual is implemented by the subclasses,
Hmm.
isn't it?
Okay.
So
Yeah.
so here virtual means this base class is it is there, but there is something actual that should happen. That actual is subclass destructor. This
Okay.
should
Okay.
also get executed. No,
Yeah,
other
right. I mean, I was not asking only on this context. Like generally, we used it for the class also, right? I
yeah,
mean,
class
for
also,
inheritance.
methods
When there is a
also,
problem.
we
A
override.
method also.
Yeah,
Huh.
the
So,
Yeah, go ahead.
Like, is the meaning main I mean, is it does it differ for each, I mean, different things, like when we use it for class, it's a different thing.
Yeah,
When we use it for right now, it's a different thing. Or when we use it for functions, like it does I mean, my question was
hmm.
virtual. See, for diamond problem, we used virtual because we wanted this
A single
class to
copy
have a
of this. Yeah,
reference.
yeah. So
Okay, reference.
you are right. I
In
mean,
this
the meaning
case,
will be different in different scenarios.
different
Yeah.
scenarios. Okay.
Okay. So
Yeah.
if you use
Okay.
with methods, no, you can override those methods. Okay.
Okay.
If you
Okay.
use with the destructor, it means you enable destruct of subclass also to be called.
To be called.
Yeah,
Okay.
automatically.
Okay. Yeah.
Right. And if you use,
Because that is, it is confusing,
yeah, yeah,
because we are
true,
using on
true.
multiple things,
Everywhere you
right?
are using virtual, so depending on the context, it will have different meanings.
Ah, yeah. Okay.
True. Hmm?
Okay, sir.
Okay.
Thank you.
Yeah. Now, we saw friend method or friend function. Uh,
Hmm.
on similar lines, we can have friend class also. Okay. So
Hmm.
that this friend class can get access to the private members of another class. For instance, you have a account class here, and we have two data members, customer name and balance. Now, I define a friend class, it should be friend here, friend class bank. So bank, this account being part of the bank, there is no risk in making bank as a friend class of account, so that the bank has access to the private members of the class. So how can I make another class as friend of this class? So what you have to do is you just go the usual way, define your class with its own constructor, methods and all. And then wherever you want to add a friend class, you just use the keyword friend, and then you would use the class keyword here. Don't say friend bank. It should be friend class bank. Okay. So that the class bank can access the private data members. Not again directly, you should again pass the object of the class in which the friend class exists, right? So in the bank, if you have a method show account details, you have to pass the reference to one object of the account class. And using this reference variable, I can access the member variables. This is similar to friend function, but just that instead of friend function, I'm using a friend class. All right. So let's see the implementation of this.
Sir, friend class can access, even though the actual class is private,
Yeah,
right?
yeah.
I mean, nothing is public in that class. Everything is
Everything is
private. Even
private.
then,
Still, it
a
can access,
a
but
friend can
through
access.
the reference
Uh,
variable, to the object reference. Not,
but it cannot modify.
yeah, it can.
Okay.
Okay, so let's see that in
Okay.
action.
Okay.
Let us say class account, and here we have customer name and some balance amount, and we have the constructor account where you are initializing them to some value. Let us say customer name, balance equal to some 5,000. Let's say. Now I define a class bank. Within this, we have a method show. Here I can have a reference variable of account. And here I can say cout account dot customer name account dot balance. balance. Yeah, now you see a red line appearing here because I have not mentioned bank as a friend class yet. So it is not allowing me to access the private members. This is how it should be, right? Because customer name and balance are private to account class. So unless I make bank class friend, you cannot access them. So I have to say friend class bank here. The moment I do this friend class bank, the errors will disappear. Okay. Now I can create bank P. Before that, I have to create account A. So default constructor and create account B. B dot show when I call, I have to pass account A, isn't it? So it should be able to access the private data members. Is there something remaining here? Okay, this delete B has to be removed. Yeah.
So if I remember, in our friend method,
Okay.
okay, we were giving const as a particular, meaning we were passing const as a parameter to not to change the value. Over here, this will not be applicable, meaning there as well we can just give the modify the value of the friend method, right?
Yeah, in the friend class method that is show, you have access to the private data members, no? I
Right,
think so. You should be
right.
able to modify also. Suppose if I say account dot balance equal to some 9,000,
Mm,
it should reflect no. So
mm,
it was showing 5,000, now it will show 9,000, right?
okay. Mm,
So even though they are private there, you are able to access them here and modify also. If you don't
okay.
want the modification to be possible, then I think so you should use const here.
Const.
Okay, moment you say const, you cannot. Expression must be
Okay.
modifiable value. It will give error,
Okay.
right?
Yeah.
So you have the flexibility of keeping it open or
Mm,
block it.
okay.
Hmm?
If we remember that that is not the actual thing, we should not do.
Yeah.
I mean, we cannot, we didn't say we cannot, but we should not do
If
that
you use a
particular.
constant reference, then the member variables cannot be changed.
Okay.
Okay.
Mm, understood.
Yeah. So friend class is also a possibility. Yeah.
Sir, I have one question.
Okay.
So let's suppose we have class 1 inheriting from class 2,
Hmm.
and in class 2 we have uh, uh, protected member which has a class 3 object.
I didn't get you exactly. Let's say class 1
You can write
is inherited by class 2.
class 2,
Okay.
and in the class 2 we have a protected member,
Protected X. Okay.
a protected X
Okay.
member that is a that is a class 3 object.
What do you mean class 3 object? Suppose there is one class 3 also.
There you instantiate na class 3 in the
Okay,
protected
here
member. Here
class 3 like this.
class 3.
Hmm.
Like, can we access like functions of class 3 from class 1, like after create? The class 3 is in class 2.
Ah.
But sir, class 1 is inheriting from class 2, right? Whatever
Oh,
member.
class 1 is inheriting from class 2.
Uh,
Okay, okay. In that case, yes. You can access the methods of X.
Okay, okay. So next time give this scenario also, like one small.
Okay, but you
Yeah.
describe me actually what is your problem and what you want me to explain.
No, just I wanted to
So
know, like, because
class
they,
two is inheriting from class one is inheriting from class two,
class two, and
and
in
and in
class two we
class two
have
we
a
have
member that is also another class
mhm.
bus.
Yeah, then no
Mm,
problem. Class one will have access to this protected member.
protected member.
Then X
Mm.
whatever methods and variables are there, they're accessible in class one. Absolutely no problem. Hmm?
And we can modify those class 3 members also in class 1.
Yeah, protected, they are derived into class one, then you should be able to modify also. Yes.
Okay.
Okay, so
Okay. I got.
protected are like public only, but within the base class, in its own class and in the subclasses. Hmm?
Mm-hmm.
Yeah. I
Sure.
have only so much to present today. So what we saw today is how we can have light coupling between classes with the help of concept of abstraction. So abstraction basically is to hide the details and expose only the essentials. So you only expose the methods to the outside applications, and they are implemented by subclasses. So the abstract virtual methods are implemented by the subclasses, and we saw the advantage how useful it is to switch from one payment to another payment type in the shopping cart. So the advantage of abstract classes and pure virtual functions we could demonstrate through the example of a shopping cart. And we saw the difficulty of the diamond shape inheritance, where multiple copies of the constructors of base class were there. And to eliminate that, we have to virtually inherit from the base class, so that we'll have only one copy of the constructor of the base class, and that will be shown up when you create object of the class D. And we saw what is the problem with the destructors, that a base class reference pointing to a subclass, and when you delete base class reference, the subclass destructor is not automatically called. So in that case, you have to use virtual keyword with the destructor of the base class. Okay, so that will ensure that both the base class and the subclass destructors are called. And we saw the friend class, and the friend class will have access to all the member variables of the class in which the friend class is defined. All right. So we shall see more on these things in our next session. Is that fine?
Yes, sir.
Okay.